Alright, in this circuit, what we've got is we've got our power supply. Do it like that. There's various ways you can do AC, but we've got our circuit. Got an ammeter here. We've got a resistor here, and we'll put a voltmeter across that circuit. We'll put 240 volts through it. Now my 240 volts is an average voltage, right? We've already talked about that. Now what I want to have a look here is at the phase. Phase becomes very important in AC. And we haven't talked too much about phase, but basically with the voltage and current is what we're talking about here. And so when you look at the AC voltage, remember what we said, the AC voltage goes like this. Now the voltage across the that's from the source. Okay, so the voltage across the resistor, if it's in phase, we've done this with waves, it will also follow the voltage across the supply. So they go at the same time. What I mean by that is when this one's up, this one's up. When this one's zero, this one's zero. When this one's down, this one's down. That sort of thing. When this one's zero, this one's zero. So they're in phase. Now, if the voltage in the resistor, is in phase with the voltage on the supply, we need to also talk about the current. Now, the thing we'll find with the resistor is that the current is always in phase with the voltage in the resistor. So the current, if we put it on here like this as current, then it is in phase with the current. Sorry, the current is in phase with the voltage in the resistor. That's the current in the circuit, by the way, because you can't have a current in the resistor different than the current over here, or over here, or over here. The one thing you can rely on in these circuits is that the current is the same throughout the circuit. Every component has the current is the same. That's the one thing you can rely on. The voltages will be different in different components at exactly the same time, but the current through the circuit will be the same. So a way of drawing these little circuits as phases. Remember the phases that we did? We did phases in SHM, and we drew that phasor diagram. Remember the phasor diagram where we had a displacement vector, we had a velocity vector, and we had an acceleration vector. That was our phasor diagram for SHM, remember? We're also going to, and basically with the phasor diagram, the whole thing rotates around, and if you project the components, you can find out at any particular time what the value of D, V, or A are. So in this type of diagram, we had displacement and acceleration 180 degrees out of phase. That means they are in phase, but they're 180 degrees out of phase, which means that when this one is maximum positive, this one is maximum negative, and vice versa. This is 90 degrees out of phase, and so when this one is maximum, this one is zero. That's what we found from SHM, and it's a very similar situation in AC, which is why it was so important to understand those phasor diagrams. So looking at it from that point of view, if we want to draw a phasor for the VR, that's my phasor for VR, voltage across R, the resistor. This is my electrical circuit now. I just said the current was in phase, so if that was my current phasor could be totally with that one. And I could also have my, I'll put it in red just so you can see it on top. This would also be my Vs. So they'd all be in phase going around together. And that's the way this diagram would look. Now it gets a little bit trickier with the capacitor and the inductor, which we're going to look at next. And then we put them together. So we'll put them together one at a time first, then we'll put them together as an LCR circuit.